Hello friends, so today we are solving this problem, find the number of ways to place peoples, second part of this problem. So we are given a 2D array points of size n cross 2. Okay, so you can read about this question yourself obviously, but let me go in a simple language that what we are actually supposed to do. Okay, for example, you can see here we are given a points array, 2D array, right, like this. Okay, now there are two person, Alice and Bob. Okay, so we have certain rules to place the Alice and Bob, so we'll discuss about that. So you can visualize, for example, these are our points given in the question. Okay, so there is a lady called Alice and then one another guy called Bob. Okay, we have to place them on these points, and there are certain rules that how Alice want to get placed on these points and how Bob wants to get placed on the these points. Okay, so the points here is like Alice wants that she would be always on the upper left corner. Okay, and Bob should be on the right down bottom right corner. Okay, so that is the criteria they have, but one more criteria is there should no one under this line. If for example, let's say we are putting Alice here at 2 6. Okay, because this is upper left corner, so let's say Alice is placed at 2 6, and for example we are placing Bob here at 6 2, right? So let's say Bob is being placed here 6 2. This is a right down corner, right? So it looks like this is placed, but see here this 4 4 point is lying on the this line, so no one should be on the line. Okay, and no one should be below the line. Okay, so if we draw a line like this, if we connect these points, you can clearly observe that first criteria that Alice is on the upper left corner, that is fine. Upper left corner is fine, that is passed, and Bob is on the right corner, right bottom corner, that is also fine. RC, right bottom corner, that is also fine. But see here, no one should be on this line. Okay, or below this line. So 4 4 is basically on this line. You can clearly see that if we get the slope of it, what would be the slope of this line? 6 minus 2 divided by 2 minus 6, right? 2 minus 6. So this is giving like minus 1 to us. So this is clearly saying that this 4 4 is also lying on the same line. Okay, so there is a violation, so we cannot put Bob on 6 2, because even it looks like right corner, but 4 4 is lying on it, so we cannot go. Then what to do? So what if I place Bob here? In that case what will happen? See here, no one is there on the line. Okay, no one is below it in the sense, if we draw a area like this from here also, if we draw like this, so no one is below it, right? And no one on the line also. So in that case, like these could be like 2 6 and 4 4 is a pair, but 2 6 and 6 2 cannot be a pair. And also we can take one more scenario. For example, let's say, so now our this 2 6 and 4 4 is a valid location where Alice can be come at 2 6 and Bob can come at 4 4. Now let's say there were another point. Suppose there were 3 2 also was there. Let's say 3 2 is there. Can still 4 4 be the location? No, because if we put Alice at 2 6 and Bob at 4 4, then there is a point which is below it. 3 2 is below it, right? If we draw a line, it would be below it. Yeah, it would be under this, so this also cannot be a position. Now in this case, what would be the valid position? In this case, if we put 3 2, so instead of putting 4 4, Bob can be placed here on 3 2, right? So it can come like this, because anyway 4 4 if we keep, then if we can go in this way, Bob can come here. So basically what we mean to say is, it's two criteria that no one should be on that line and no one should be below that line also. Below in the sense, if we draw a like this a rectangle, if we draw like this, then 3 2 is basically coming under this region. So that is why 4 4 in this case would not be the solution. So we have to pass this criteria. That is only thing that we have to do. We can take one more scenario. For example, let's say these points would be something like this. Let me remove these all, and if they were, we can take the one example given in the question itself. So you can see here in the example 1 what it is given. The points are 1 1 2 2 3 3. Basically they are lying on the same line, so we can have something like 1 1 would be here, 2 2 would be somewhere here, and 3 3 2 2, and then we would be having the 3 3. They are lying on the same line, y equal to x line basically. So this would be 2 2 and this would be 3 3. Now on these points, where can we put the Bob and Alice? Is there any possibility to put Bob and Alice? So what is the left corner here? This would be the left corner here, right, and this would be the right corner, but this is not a right bottom, so we cannot place here. This should be like, let's say if I place Alice here and Bob here, but this is an upper corner basically. So our assumption here is like the question says that Bob should go to the bottom right corner, but this is not a bottom right corner, so this will not be a possible. Can we put Alice here? If let's say I put Alice here, where can we put the Bob? So in that case, this Alice has to go to the left corner, right, upper left corner, but this is not the left corner, so we cannot place anywhere these guys to get this combination. So this would be like there is a 0 point where we can put the Alice and Bob, so no possibility at all. So now you guys would have got some idea that what we have to do. Now let's go to the previous example, which will make a better sense while we would be writing our code. Okay, so you would have observed here that the x-axis is like, because Alice has to be placed on the left corner, right? So x-axis would be smallest at that time, right? And now from this point we have to find a greater x value where the y point is smaller. You can see here the all legit value, it would be a lower right corner only when the y axis, like here it is 6, then we have to find a smaller y and greater x, right? So if we go in this way, you can see here we have found the smaller y at 4 also, and but when we found the smaller y at 4, this is 4 4, so which is lesser, this x is so here we started y equal to 6 and we found a smaller y here 4 and x is greater. But before that we have also find this 3 2, right? So that is also smaller, because if we get 4 4 then this is coming under it. So basically we have to monotonically increase the x and we have to look for the smaller y. Okay, so in this way what will happen, now you can get one idea that if we sort this points array based upon the x-axis, okay, so one by one we will be like we would be increasing the x and we will try to get the first highest y. Okay, so in that case when we would be sorting it based upon x-axis, we will find the points and that first one should be our answer. If that condition is not getting matched, then we would be keep on going. Now it is not only the matter of finding one point, there could be multiple points where Alice and Bob's can be placed, right? So we have to find all of them. So let's look for the code part of it. So now you guys can clearly observe that in this case, if 3 2 was also there, in this case how many points would be there? One point would be 2 6, Alice can be placed at 2 6 and can be Bob can be placed here 3 2, right? So it would be like this. So now you can clearly see that Alice is on the left corner and Bob is on the right corner and no one is below them. So this is one pair. So we can say 2 6 and 3 2 is a valid pair, right? We can put 2 6 Alice and Bob at 3 2, right? So we found two pairs here. One, can we find further more pairs? You guys can observe here that if I connect this 3 2, okay, is 3 2 and 6 2, right? If connect 3 2 with 6 2, I can place this guy Alice can be placed at 3 2 and Bob can be placed at 6 2, right? Then also they would be passing the condition because no one is below them and this is like left corner and this is the right corner. So we found another pair here like 3 2 and 6 2, right? This is also a valid pair. Okay, so we found here total 4 pairs, right? These are the locations for Alice. This is for locations for Alice. This is locations for Bob, right? So we have to find such kind of things. So it's not only that we have to find. So see here, if we are placing Alice at x, any x point, let's say 2 6, then we found the valid condition. So we found 3 2. Now there would be a case when we would be placing Alice at 3 2, then we have to find further values. So any value which is on the top, that is fine, but it should not be on the line. Now you might, some of you might have a question, then why cannot place here this Alice, this girl can be placed here at 4 4 and Bob can be placed here. This also a combination, but no, if we go in this way, then 2 6 is lying on this point, right? And nothing should be nothing should be lying on that line, right? So this cannot be a combination, because then 2 6 is on this line, right? You can clearly see here. So we cannot go in that way. We have to satisfy these conditions that anything should not be on the line or below the line. Okay, so we have this line is a valid line, 3 2 and 6 2 is also valid line. We cannot have 4 4 and 6 2. So this is what we have to do. Now let's go for code. We will write the code together here. So let's say this is our int result equal to 0, and I'm sorting it. Okay, so I'm sorting this points array based upon x-axis. Okay, so see here, when a0 is not equal to b0, means these x and other x are not equal. In that case, what is happening? We are looking for the increasing value of this x-axis, right? We are sorting based upon the x-axis. Otherwise, if that is not the case, then what we are doing, we are basically doing this y-axis, right? So we will write it b1, y-axis is going in decreasing way, right? b1 minus a1 we are doing. So if they are same, then first it would be coming the higher value of y-axis in case of x-axis are equal, right? So that is why we are doing in this way. So now after sorting this, what we will do is we have to have the certain max and min variables so that we can check our conditions, right? We will check for all the set of values. Okay, you can see here, after sorting this points array based upon x-axis, what we are doing is we are traversing through this array. Now you can see I equal to 0 to I less than or equal to length minus 2. We are going up to second last element of this points. Why? Because these are the possible positions for Alice. Now on the right side we have to find the Bob's position. So that is why we are stopping at the second last position, because at least 1 point should be there on right side for Bob. Okay, so we are taking the whatever value is coming, right, 2D array, right? So we will get the tuples. We are taking it in here. Now we are starting these 4 variables, x min, x max, y min, y max. So this x min I have taken d0 minus 1, basically whatever is the x-axis at this point minus 1, I am taking this as the x-axis value. Why? For example, you can see here we are starting x equal to 2, right? So we are taking x min equal to 2 minus 1, because there could be a point which is lying on this line. So minimum value should be whatever value is here minus 1. So that is why we started x min equal to d0 minus 1. X max equal to, we are taking the maximum value, because we don't know on right side we can go to up to any value. Similarly for y min we are taking the negative values, we can go any way going down. But y max is we are taking d1 plus 1. Now again you might have a question, why this plus 1? So this is the y value, right? 6 value. So we are looking for all the values which are on the right corners, right, for the Bob placement. So y value we are taking x plus 1, so it should always this y plus 1. So that would be the max value, because there could be a possibility that line is like this. So this max value should be plus 1. We cannot go to equality, right? So that is why we are taking y max equal to here or d1 plus 1, because something might be on the line as well, right? Okay, so for that reason we are taking. Now we have to compare these values. So what we gonna do is we will again use the for loop. Now this for loop would be int j equal to whatever is the I plus 1, because we are looking for all the right side locations for the Bob. Okay, so j is equal to I plus 1 and j is less than whatever is the length of this points dot length less than this and j plus plus. Now what we gonna do is again we would be having some, let's say we are taking this in int d1 array, so whatever value is there, so points and j, we are taking these values. Now what we have to do is we have to check for the condition. Okay, so you know that x would be, where would be the int x would be here on the d1 of 0, right, and y coordinate int y would be on the d1 of 1, right. So we have this condition. Now we have to look for the boundaries, that if this x is less than the min x, x min, right, we have created here x min, so this guy should be less than greater than, sorry, x should be greater than x min, right, and x should be less than x max, okay, and this y should be greater than y min, like this, and y should be less than y max. This is the condition. If this condition is matching, in that case we can say that something is like this point, we started for this point, this point is potential point, this point is the potential point for Alice, and if this condition is matching inside this for loop on the right side, if this condition is matching, right, you can see in this diagram that if we take 3 2, then this condition should be matching. So 3 is greater than this x, right, and y is smaller than this y max. Similarly we are doing same thing here, that x is greater than x min, x is less than x max, y is less than y min, and y is less than y max, right. So this should be like this. So if this condition is matching, what we're gonna do is basically we have found one potential pair, right. So we are taking answer plus plus in this case, right, and we have to update our this x min and y min now, right. So our x min would be whatever we found here, this would be x min would be our x, right, and our y min would be y, right, y min would be y, and now we have to keep on doing in this way. So you guys can observe that I is traversing up to the second last locations, so that we will look for all these potential pairs where Alice could place and Bob could be placed on the right of it, if this condition is matching. So this is so whenever we are getting, we have to write this result res plus plus, what is the variable name we have, res plus plus, and finally when we will come out of these loops, finally we would be having the result value as our answer. So we can see here return res. So let me execute this code. So I'm executing, there is some issue here, so okay, there is a semicolon missing there, so let me do that. This would be equality basically. So let me run it now. Okay, this name is also points. Is there some more issue? Yeah, so let me try to submit it. Yeah, so it is accepted. So what is the time complexity here? You guys can see here we are using this for loop, and for every I, right, in the for every I this for loop we are looking for remaining right side locations for the Bob position, right. So this is definitely O of n square time complexity here. And what about space complexity? Are we taking any extra space? No, we are not taking any extra space, but yeah, we are parking these values here. So it is like O of n as the time complexity, space complexity, and O of n square would be the time complexity. So thank you for watching this video, and if you guys have any concern, please make a comment over there.